So I'm not sure where you're at as far as from factoring, and one thing that's hard about this question, that people find hard about this question, is that there's not just m squared or x squared, so you have to be able to come up with some way of doing this. And one way that many people find useful when they're first learning how to do this factoring, it's called the AC method, and what you're going to do is you're going to multiply the first term by the last term, or the first coefficient by the last term, and then just pretend that it's the 5 is gone for a minute. So I'm going to write as m squared minus 41m plus 40, and then what happens is I can factor. Well, let's see, what gives me m squared? Well, m times m gives me m squared, and then what will multiply to give me 40? That will add to give me negative 41. And I think 40 times 1 is 40, and then 40 plus 1 is 41. And the only way I can get a positive 40 is if they're and a negative number in the middle is to make them both negative. And then you remember that 5 that I just kind of ignored for a minute? I'm going to come back and I'm going to divide each of these factors by 5. So that's going to leave me, and then of course 40 divided by, and simplify it if you can. So 40 divided by 5 is 8, so that becomes m minus 8. And then unfortunately 1 won't divide evenly by 5. So this is certainly a way to leave the factor m minus 1/5, but typically what we'll do is we'll say, okay, well, let's clean this up. We'll multiply by 5. That kind of comes from, if you think about this as an equation. If I were to multiply this by 5, that would give me 5m equals 1, and 5m minus 1 would be 0. So that's my factor, 5m minus 1. And then, of course, you should multiply to check. M times m, 5m is 5m squared. Negative 1m from that multiplication. Negative 40m from that multiplication. If we combine those terms, we get negative 41. And then we're at negative 41, same one, I guess. And then negative 8 times negative 1 is positive 8. So we did factor that. So this is called the AC method, and it works when you have a leading coefficient other than 1. You can go find this. There's plenty of examples like this on YouTube or even Khan Academy. So that's that problem. Now for this next one, what I noticed is, this is the difference two squares factoring pattern, because there's no middle term. And I'm also noticing that this is a perfect square and this is a perfect square. So one way to figure out what I'm going to factor and what I'm going to use is to take the square root of both of those. Notice I'm ignoring the negative. So that becomes 5n, and that becomes 4. And the only way I could get a middle term, a polynomial without a middle term like this, is if these were opposite signs. And that's the difference of two squares. Okay, so that's something you can notice. And then if we put this together with your next question that you had, like how do you factor a rational expression? Well, you had one that was a little bit different than this. You had a difference of two squares on top. But what I can do is, basically what you do is you factor the numerator. In this problem's case, I'm just going to factor out a GCF of 4, I'm sorry. And the denominator, I'm not seeing a GCF, but we can do that same, if we need to, we can do that same AC method, because the 3 is in front, so 3 times 10 is 30. And then I'm asking myself, what will multiply to give me 30, positive 30, that will add to give me 13, and I think that's 10 and 3. So x plus 3 and x plus 10. And remember that 3 that I divided by, that I ignored in the beginning? 3 divided by 3 will be 1, so x plus 1 is one of the factors. And then if you think back of how I did that multiplication trick, the other factor is going to be 3x plus 10. And then I notice I have a common factor, x plus 1 on top, x plus 1 on the bottom. So this will simplify to 4 over 3x plus 10. And that's how your problem is very similar. You're going to have the difference of two squares on top that you're going to deal with. This same kind of pattern that I did up above will be there. So your problem that you had like this was not exactly like this. What you had is you had it equal to 0. So then you're going to use the zero product property, it's called. But that tells us if a number times 0 will equal 0. So if we can find the 0, so for this problem, I'm going to ask myself, where does 4v plus 8 equal 0? Well, I can subtract 8. That gives me 4v equals negative 8 divided by 4. V equals negative 2. So that's one of the zeros. Then for the other one, we can do the same thing because we know that 0 times a number is also equal to 0. So when does 4v minus 7 equal 0? Well, same deal. I'm going to add 7 divided by 4. I hope you're all right with me just jumping to that. Okay, it's the same kind of ideal there. And this is when they give us a polynomial in factored form. And if there's 3 terms, you just use all 3 terms and do them individually. So in a problem like this, we got parentheses on both sides. We got an inequality. We have to solve this inequality, and then this is telling us to graph it. Your question doesn't look like you had to graph it. So I'm going to distribute. In order to remove the parentheses, I'm just going to distribute that 2 through. That gives me 10 minus 4p. The mistake that people typically make was they'll forget to multiply the 2 by the 2p also. And that's going to be less than or equal to. Then I'm going to distribute the negative 2 through. So negative 2p plus 14. So I've gotten rid of the parentheses. Now it's good to solve this, get the p's on one side of the equation. So in this case, I'm going to decide, I'm going to choose to add 2p to both sides. And I'm hoping, if you see that, I can also subtract the 10 from both sides. Do that all at once, and that leaves me negative 2p on the left is less than or equal. The 2p's are gone on the right. 14 minus 10 is 4. And then I'm just going to divide by negative 2. And then the issue with inequalities is you've got to always remember, when you divide by a negative number, the number that's with the variable that you're dividing by, if that's negative, you got to remember to reverse the sign of that inequality. So that becomes p is greater than or equal to negative 2. And then, of course, to graph this, I'm going to do what depends on your book. Some books use brackets. Some use, one way to do this is put a point, a colored in point on the line, and shade to the right because this is greater than negative 2. That's one way to do it. Another way to do it is not use a point, but use a bracket. Because it includes negative 2, I want to use a bracket. If it didn't include negative 2, I wouldn't use a bracket. I would use a parenthesis. And then a shade to the right again, because that's that. So hopefully that'll help you do that part. And then the only question that I haven't really answered for you is one like this. So here's a problem. It's a variation, kind of like what you did. Now, because I've got w's and z's in this equation, I'm only going to be, it's called a literal equation. I'm only going to be able to solve it for one variable equals another variable. I'm never going to be able to get rid of my variables. So I'm going to choose to move my w's to the left and the z's to the right. It doesn't really matter. But one thing we can do to make our work a whole lot easier is to get rid of these fractions. So I'm looking at 4, 6, and 3, and I know the smallest number that all 3 of those will go into evenly is 12. So what that tells me is I'm going to multiply both sides of this equation by 12. And while it seems a little more awkward at first, it's going to see shortly that it's going to become a much easier question. So then what I'm going to do is just distribute that 12 through both of these terms. 12 times 5 is 60w. And then with the next part, 12 times 2 over 3. Well, you could think of this as 24 divided by 3 and get 8. You could also take the 3 and cancel into, or simplify it. 3 into the 12 is 4 times. 4 times 2 is 8. Either way works. Either way, you're going to get 8z. This side I'm going to multiply by 12 also. So 6 and 12 will simplify to 2. So on the right hand side I'm going to get 2z, and then 12, 4 goes into 12 3 times, so that gives me 3w. So now I don't have any more fractions. I can just start dealing with the w's and the z's. So I'm going to add 3w to both sides, move the w's to the right. Doesn't really matter in this case. And I'm also going to subtract the 8z from both sides. And that's going to leave me 63w. There's no more z's on the left. Negative 6z on the right, and there's no more w's on the right. And then if I'm going to solve for w, I'm just going to divide by 63. And let's see, does 6 over 63 simplify? I think so. I think they both divide by 3. So that would be w equals, let's see, divide by 3. So that would be negative 2 over, what is that, 21z. And that is what that expression is equal to when you solve it. So hopefully this helps you solve your problems. Don't hesitate to come join us in a live chat.